myself Ajit Pratap Singh. Today in video number 39 I will tell you about the Earth's magnetism. Apart from this, I will also let you know about the magnetic compass. Okay students, so let's start with the Earth's magnetism. Why does a freely suspended magnet always come to rest in the north and south direction? Do you know students why? Because the Earth itself behaves like a huge bar magnet. Okay, so in this the Earth itself behaves like a massive bar magnet with its magnetic poles, which are near the geographical north and south poles. The south pole of this bar magnet is near the geographical north pole, whereas the north pole of the bar magnet is near the geographical south pole. Okay students, as you can see in this diagram as well, that north is facing the south of the bar magnet, and the south of the geographical south pole is facing north pole of the bar magnet. Now the next slide. In a freely suspended magnet, therefore, the north pole points towards the geographical north pole. So we can say, in a freely suspended magnet, the north pole always points towards the geographical north pole, since it is attracted by the Earth's magnetic south pole. So the Earth's magnetic south pole is attracting the north pole. Similarly, the south pole of the suspended magnet is attracted by the Earth's magnetic north pole and therefore points towards the geographical south pole. Now we will talk about the magnetic compass. Okay students, magnets were first used as compasses for showing directions, that is north, west, east and south. A compass consists of a magnetic needle. So there is a needle in between the compass, which is pivoted at the point so that it is free to rotate about that point. Okay students, the needle points in the north and south direction, provided it is kept away from the another magnet or other magnetic materials. It can therefore be used to determine directions that I told you: east, west, north and south. It is especially useful for sailors, especially in the water. Okay, now the next slide. Now I'll let you know about making magnets, how we can make the magnets. A piece of iron can be magnetized by using a magnet in the following way. So we can magnetize a piece of iron by the following method with the help of activity number 6. Okay, that is the 14.8 figure. For this we have to first of all place an iron needle or a bar on a table. Now we will hold it down firmly, and now we will stroke it about 30 times from one end to the other with one pole of a bar magnet. After you reach the other end, lift the magnet high and bring it back to the first end. Now test the needle to see if it has become a magnet or not. Suspend it freely to see which end has become the north pole. So as you can see, there is a needle and there is a end also, end 1 and end 2. you will find that if you stroke with the north pole of the magnet, the end of the iron bar from which the stroking is started, that is end 1, becomes the north pole. So that becomes the north pole. The other end, that is end 2, becomes the south pole if you stroke with the south pole. So if you will stroke from the south pole from a magnet, then it will become south pole, and if you will stroke from the north pole, then it will become north pole. The poles in the iron needle will be reversed. This is known as the single touch method for making magnets. So by this method we can make the magnets. Now we will talk about using electric current. With the help of electric current also we can make a magnet. The above method of magnetization, that is single touch method, is no longer used. Nowadays all magnets are made with the help of electric current. Okay students, so nowadays the single touch method is no longer used. Instead of this, electric current method is used for making a magnet, and you will read about this in the upcoming higher classes. Okay students, so that's it in this video number 39. Now I am hopeful that you will be able to tell about the Earth's magnetism, apart from this magnetic compass, and how we can make a magnet very easily. So thank you very much for watching this video.